mode.
Hi everyone, welcome to today's webinar, Hazardous Waste Management in Higher Ed. We're glad you could join us. My name's James. I manage webinars and events here at Triumvirate, and I'll be your moderator for today's event. And before we get started, I'd like to give you a brief overview on what this webinar is going to entail as we run through a few housekeeping items. First, please note that all microphones are turned off for the entirety of the webinar, but if you have a question or a technical issue, you can use the questions box to communicate. And for those of you who were with us 2 weeks ago, I've been assured by our webinar vendor that the audio issues have been resolved. So we should be all set today. But in case you do experience some difficulties, please communicate with us and we'll take care of that. There will be live polling during the webinar. We've got 2 polls that will be launched, so please be sure to participate in those. Following the presentation, there will be an open question and answer period. And you can ask questions anytime throughout the webinar just by submitting using that questions box, and we'll take care of those at the end. And finally, we'll be announcing an offer at the end of the webinar to help assess your hazardous waste management needs. And we'll do that just before the Q&A, so please stick around for that. I am pleased to introduce 2 speakers today. We've got Melanie Magnan, who serves as the Regional Director of Higher Education here at Triumvirate. In her current role, Ms. Magnan manages clients, account managers, technical services representatives, and environmental specialists. She's responsible for the success of the higher education niche in terms of not only the satisfaction of current clients, but also the development of new ones. And Mel is joined by Nikki Young, who is the Southeast Higher Education Program Manager for Triumvirate, and she's been with the company for about 3 years. She holds a bachelor's degree from Bradley University in environmental science, and currently provides environmental services to a majority of the colleges and universities throughout Florida. She's got a great grasp of the federal, state, and local regulations. And so with that, we'll start with Melanie. Hey, Mel.
Hey, James. Thank you very much. Thank you, everybody, for attending the webinar today, taking time out of your busy summer slammer schedule. Also, for all of those that might have attended the SHEMA conference last week and who might be attending the Hazardous Waste Conference next week, thank you for taking the time out of your schedules to put Triumvirate's webinar right in the middle of your conference sandwich. So let's get started. Our key message today is that we're going to learn how to use regulations and waste minimization options to improve your waste management process and to ultimately achieve some of your organizational goals. So if you're attending this webinar today, hopefully you fit into one of these brackets. Perhaps you're a school looking to minimize waste generation, and perhaps you're not being provided waste minimization options currently. Or perhaps you're a school looking to reduce waste disposal costs. Do you have innovative strategies for managing waste from cradle to grave? Or perhaps you're a school looking for better waste tracking systems. Every program is a little bit different. Every school is a little bit different. Do you have a software that is customized to fit your needs? So no matter which one of those brackets on the previous slide you fit into, here's what everyone's going to learn today. We're going to take a look at the regulations and see if we can use them to our advantage to reduce some costs. We're going to look at elevating the hazardous waste storage area to perhaps meet some of your budgetary constraints. Then we're going to look at waste from start to finish, from upstream, where it is generated with the researchers, all the way down to the main accumulation area. And in that process, we're going to look at why it's so important to have a waste tracking program that can track your waste from cradle to grave, which will help improve efficiency and save time and eliminate confusion. So here's our agenda for today. We're going to start at the top and look at the upstream waste management process. But before we get started with that, just want to get the juices flowing a little bit. We have our first poll question here. It'll pop up on your screen. Which department's waste generation challenges you the most?
And we'll give everybody about 15 to 20 seconds to respond. Looks like we've got almost everybody responding already, so I'll share those results in a second, Mel.
Thank you, James.
All right, looks good. Let's push those out. And maybe no surprise here, but as you can see, 74% chose chemistry, another 9% biology, 6% arts, 4% engineering, and 6% other.
Thank you, James. Thank you, everyone, for participating. I'm actually not too surprised with chemistry. If they're making new chemicals every day, that certainly adds the challenge of figuring out how to handle the hazardous waste from their research. So no matter which one of those selections you had, hopefully the upcoming webinar and some of our suggestions help you to manage the waste coming from each one of those departments. So we'll start at the beginning, where waste is being generated. For the sake of this portion of it, we'll just call those generators researchers. So we have 4 reasons here why it is so important to work with the researchers at the point of generation, and we'll go through each one of these reasons. Most important is actually having an understanding of how that waste is generated. At that point, we can determine if the waste container is the appropriate size for the generation process. We can determine if the waste bottle is made from one process, or are there so many different processes in the lab being poured into one container? Is that a good practice? Working with the researchers will help you understand if a waste code is applicable to that bottle, just because it might say hydrochloric acid on the waste tag and it gets the D002, understanding if the percentage is high enough to warrant that code can be determined at this process. For machines generating waste, such as an HPLC machine, there are always multiple lines going into the same waste container. However, could there be a line that could be taken out of the hazardous waste container and put to a different location? Lots of machines, like HPLC machines, have a condensation or a water line that is better suited for sink disposal than being added to the hazardous waste bottle. And then understanding how waste is generated, you can understand the timeline of that process or research. And this can help you manage your inventory of waste volumes and help with disposal costs. The second reason why working with researchers upstream is so important is once you have an understanding of their process, you can also educate them on proper waste collection techniques. Are all the chemicals that they're putting into one waste container compatible? And as EH&S professionals, when you understand where the waste is going for final disposal, you can also say, do the chemicals perhaps pose another hazard when they're disposed of at the final facility? Help educate the researchers on whether or not some of the chemicals can be disposed of using different treatment techniques for cost savings, like recycling. And then as EH&S professionals, probably have a really good understanding of your facility's wastewater discharge permit as well as other state regulations. So can you use that to your advantage, and maybe some of the hazardous waste can go down the sink versus being collected and disposed of in a more costly manner. The third reason why working with researchers upstream is beneficial is you have the ability to discuss chemical substitutions with them. Is there a chemical that is less harmful to the environment and oneself? And can that chemical help be diverted to a less costly waste stream or disposal options like the sink or the solid trash? The 2 examples that you have up here on your screen, the first one is substituting alcohol thermometers instead of mercury thermometers. Not just from a disposal cost, but mercury spills are very costly from an emergency response standpoint. The beads go everywhere, and those vapors tend to linger for quite some time. So that's a pretty common substitution that a lot of schools are going towards. And the second one is perhaps using cyber-safe gel stain instead of the carcinogen ethidium bromide. But with all chemical substitutions, there are pros and there are other things to consider, like the historic knowledge of such a research. Does it require a specific chemical to be used? Perhaps the time frame of that project may inhibit such a substitution. And or perhaps funding may not approve if a chemical substitution was to take place. And the fourth reason for working with researchers upstream is being able to help manage those costly, time-sensitive chemicals. Working upstream, you can identify those who are using or have in their possession time-sensitive chemicals such as peroxide formers or picric acid that is not yet dried. You can help educate those individuals on the hazards associated with those chemicals and the hazards associated if those chemicals were to expire. You can work on setting up a tracking system to dispose of such chemicals well before their expiration dates. And as you can see on the picture on our screen right now, there was certainly a bottle in there that probably shouldn't have been there, maybe expired, had a little reaction, broke on other bottles in that bin and caused an emergency response. That is costly. So doing all of this will certainly help lower overall disposal costs and overall emergency response costs. Nikki, do you want to take it away for waste regulations and storage?
Absolutely. Thank you, Mel, and thank you everybody for attending today. The next thing we're going to look at are the waste regulations and storage, and can these be used to help us maintain lower costs for disposal. The background on our regulations. Regulations can be used to one's advantage to store waste longer. Although they may be very complicated and even scary to some individuals, knowing them can be advantageous to your storage needs. So using the regulations to your advantage, there are some common misconceptions out there. For example, small quantity generators a lot of times believe that they can only dispose of 2,200 pounds of hazardous waste per shipment. This is not necessarily true. What the regulations actually state is that a small quantity generator can produce 2,200 pounds of hazardous waste per month, or 2.2 pounds of P-listed material per month, which would essentially allow a small quantity generator to dispose of 13,200 pounds every 180 days, which is the generation accumulation time for a small quantity generator. So in order to be able to store that many chemicals, you may be thinking, I need to set up some storage areas. Well, any room could be a storage area. It doesn't have to be some small little room or a back area. Storage areas can be anywhere. And they can help maximize the length of time that you can store waste. Various areas, including outside, can be used for storing hazardous waste. The requirements are they need to be delineated by maybe fencing or tape. Proper signage has to be placed in the area of this waste storage. There must be spill controls in place and proper ventilation. If you have all of these items, you can store waste in multiple areas of your facility. So will storage actually help you save in costs? This again goes back to the regulations for generation and storage. Storage can help save costs by reducing the number of times a truck is dispatched to remove your waste. Most waste brokers will include a transportation charge somewhere in the process, and if you can dispose of your waste less frequently, you can reduce those transportation costs, thus reducing your disposal cost. You also want to determine what you are shipping each time based on your generator status, so how long you can actually store your waste. You only want to ship full drums. If you have a drum that only has maybe 2 inches of solvent in it, and that drum is only a couple days old in your main accumulation area, you might want to hold that for your next shipment instead of including it on the current shipment. And finally, the energetic materials and compounds. Those should be shipped at the next appropriate shipment time. The longer they sit in your storage facility, the closer they might get to expiration. And we don't want them reacting in your MAAs and causing a high hazard team to have to come out and stabilize the materials. That ends up being a much more costly process. So we have a couple of real-world examples of how universities have changed their storage processes and have been able to save relatively large amounts of money. In the first case, a large university has multiple MAAs, and they're all over campus. So they used to bring their waste to the more, the closest MAA to them. They found that, however, centralizing where they took their more expensive wastes or the reactives and mercury wastes and centralizing that in one area seemed to help with their disposal costs. They also moved some supplies out of some MAAs and into a different MAA, allowing for more room for storage in the MAAs. By doing this, they've come up with a total annual savings of $109,000 per year. And our next real-world example, there was a large public school, and they were shipping their waste out monthly because they couldn't store it. They were spending $15,000 a month on their shipments. So with Triumvirate's help, they decided to dispose of the full containers every single month, or waste that was at their storage limit based on their generator status. By doing this, the waste budget was decreased by 40%, and to help the regulators actually determine whether or not they're in compliance, they are using a software program to track the information regarding the waste remaining in the MAA each time. So before we move on to the next section of our agenda of waste minimization and disposal, we have another poll question for you. So what is your greatest challenge when it comes to disposing of your hazardous waste?
Thanks for teeing that up, Nikki. The options just displayed on everyone's screen, so we'll give you another 15 seconds or so to respond to this question. The options are not knowing all of the waste streams, selecting a TSDF or new treatment technology, managing costs, commingling waste, and other. So please respond to that, and we'll share the results. All right, pushing those out now, Nikki. So tied at 30%, we have managing costs and commingling waste. And then at 28%, not knowing all of the waste streams, 9% other, and 2% selecting a TSDF or new treatment technology.
Well, that's not a surprising answer either. Not knowing all the waste streams and trying to manage costs, commingling wastes, all three of those kind of fit in the same category. Do you commingle waste? Don't you commingle waste? We're actually going to look at that in the next section of this presentation. So we're going to look at what a waste minimization assessment actually is. In this case, we are going to look at all waste streams from the point of generation to storage in the MAAs and ultimately the final disposal. We're going to identify what should and should not be commingled to achieve cost savings and the use of the most applicable disposal methods from recycling to incineration. And finally, we're going to help you understand the entire cradle to grave process. So we're going to begin by conducting an accurate waste inventory in our main accumulation areas. The inventories help you document the amount of time the waste spends in the main accumulation area to ensure that you are being compliant with your generator status. When a bottle enters the main accumulation area, you should label the material properly with all the constituents and date the bottles when they enter the facility. You want to also document exact quantities of P-listed materials. When determining what to ship, you only want to ship full containers or the containers that have hit the storage limits based on the regulations. And by maintaining the records in the MAA for the federal, you will be able to prove to the federal regulation agencies how long every item has been in the MAA. Next, we want to create a proper waste analysis. This begins with the researchers. You must be able to get the constituents and the percentages of all those constituents in each bottle. The percentages can make a difference as to whether or not a waste would carry certain waste codes and whether or not it is treated in different manners. For my example of this, you may have a bottle of alcohols come in that contain a small amount of methylene chloride. Without the percentages, you cannot accurately determine whether or not that material is a halogenated waste, which would have to go for a much more expensive treatment method, or a non-halogenated waste, which can be disposed of in a much cheaper method. You also have to be able to determine when to use waste codes. Not all waste codes are applicable to all wastes. You listed waste codes, for example, are only for virgin materials. So if you receive a bottle of spent solvents, a U-listed code will not apply. Also, some P-listed waste codes are no longer applicable if the waste has gone through a process, rendering it no longer acutely toxic. And our final point is to make sure you segregate your non-hazardous and non-regulated materials from the hazardous wastes. And this includes state waste codes. So you don't want to include any state waste codes in your non-hazardous and non-regulated materials. By doing this, you can store your non-hazardous materials for any amount of time. There are no restrictions as to how long you can hold a non-regulated material within your facility. There are also cheaper means of disposal. For example, you could actually go straight to the landfill with some of it, and some can be recycled. And finally, and maybe most importantly, those non-hazardous materials do not count against your generator status. So if you are trying to maintain a small quantity generator status and you keep your non-hazardous materials separate, you can actually generate more than 13,200 pounds of waste per month as long as only 13,200 pounds of it are considered hazardous. Finally, we're going to look at commingling similar waste streams. Does it make sense or doesn't it? We should only do commingle waste streams that have similar disposal methods and compatible waste codes. Again, I'm going to go back to the halogenated versus non-halogenated example. You do not want to commingle your halogenated waste in with your non-halogenated waste. It automatically takes the end drum into a halogenated category. That drum then has to be incinerated instead of possibly going for fuels blending. Next, you want to determine appropriate container sizes. If you're only generating 15 gallons of a waste within your storage limitation period, you may want to use a 15-gallon drum instead of a 55-gallon drum. Most disposal facilities will charge you for the container size that you are shipping, not for the amount within the container. Don't mix wastes that have different treatment methods. If you can send something for recycling, it is not good to mix it with something that has to go for incineration. You will increase your costs. And finally, we do not want to add any P-listed materials to any waste streams that we commingle. Just the smallest percentage of sodium cyanide, for example, in a drum of potassium hydroxide will make the entire drum acutely toxic and will have to carry the P-listed waste code, which could change your generator status. So now I'm going to turn it back over to Melanie to talk about our compliance and waste tracking software.
Thank you, Nikki. All right, everyone, hopefully you're still with us. Rounding the bend. Now that we've looked at generation of waste upstream, regulations, disposal, tracked it through the process, let's look at the waste tracking software and why it's so important to help us with compliance. So why use a software program at all? Obviously, there's some regulations that we need to fulfill as generators of hazardous waste, like having 3 years of manifest records and LDRs and packing slips. A software program can help you to manage those documents in an orderly fashion. Software programs can provide an interactive calendar with dates so that you know when certain reports might be due to regulatory agencies. Software programs allow you to track that waste from the SAA down to the MAA and out for final disposal. By tracking your waste, programs would allow you to run reports, such as how much waste was shipped on a manifest during a specific time, or by profile. Is it a lab pack, or did you have a lot of 55-gallon bulk solvent containers that were shipped? And if it's a really good software program, you can track it down to which building produced the most waste, or perhaps which professor produced the most waste during X time frame. And then lots of software programs are helpful so that you can upload inspections to help with tracking of compliance and other regulation-related issues. Why use a software program? Some benefits of such software programs. When you're considering a software program, make sure it's really easy to use. It's intuitive. It's easy to navigate. If the program has an app that you can download on the smartphone, that is fantastic, so that it can be accessed anywhere, especially if the internet is not available. If you're in the New York City in the dungeon of a school, perhaps you don't have internet access, but the program will still allow you to work because of the app. Software programs that have automatic emails are fantastic. That way you don't have to log into the program to run reports or to get data. The data can be pushed to your fingertips at any interval that you may want. And then a software program that allows you to upload any such document that you want that can be accessed as long as you can access the program. So those are some of the benefits, and there's a ton of software programs out there. Triumvirate recognized the need for software programs, the need to try to compile one program that really houses all of the different regulatory aspects. So we designed a program called Advise. Does anyone know what Advise stands for? Silence. I kind of figured. I'll let you know. Advise stands for Analytics Developed for Visionaries in Safety and the Environment. There are 6 modules here, and I'll just pick out the 2 that are important for the rest of the webinar that we just went through. We talked a lot about waste shipments, so manifest tracking. This is just a snapshot of the front page of that module. You can see all of the manifests that were shipped, the site that they were shipped from, the status. This is where you can track your manifests. Right now everything says archived, but when you first ship a manifest it would say shipped. When you receive your manifest back within that 35 to 45 day window, you can change that to say returned. And then after 3 years, when you're not technically required to keep a manifest anymore, it'll be archived. Of course, it stays in the system. You can always access your manifest. The compliance dots move along with the status color, and then you can see your ship date and your return date. This program also does produce that automatic email, so when your manifest is due back to you at day 35, you will get an automatic email alert that says, hey, this manifest is due, reach out to your vendor and ask for the status of your hazardous waste. And then the other module that we talked a lot about is the tracking for inventory from your satellite down to your main and out the door. As EH&S professionals, I'm not sure how many of you physically go into your main accumulation area all the time. This is a good program that allows you to sit at your desk and really help manage what's going on in your main accumulation area. It tells you the container size and the quantity. If you click down, it'll tell you your waste codes. You can see the site it was generated, the building, the room, the department, the PI, whether it's a profiled waste stream of bulk, whether it's a lab packs or big drum with inner containers, and then aging. Nikki spent a lot of time about knowing your generator status. This aging is triggered by your generator status. It's green if you're good. Yellow starts to say we're approaching that 90, 100, 80 day time frame. You better think about shipping me. And red is you've expired your generator status time frame. So this is a good way to help manage your program from afar. And having information like this goes back to generating those reports. You'd be able to generate, how many reports were shipped out of the or how much waste, was shipped out of the chemistry department during a certain time frame, or how much waste was shipped from PI Whitesides during a specific time frame. And such reports might be used to display with others in your department for further waste assessments or minimization efforts to achieve some operational goals. All right, we're rounding towards the end. Now it's time to look at a couple of case studies. Is it possible to do everything that we had mentioned before? And I think you'll be surprised that it is possible. So in this first case study, we're looking at a marine research institution that was generating a significant amount of 5-gallon carboys with a low percentage of acid in seawater. Using the regulations where this institution is located in, they are able to treat D002 corrosive waste through a process called elementary neutralization. So Triumvirate worked with the institution, worked with the regulations, and developed an elementary neutralization unit where the 5-gallon carboys were poured into the unit at their wastewater treatment plant. That acid was actually mixed with the base in the treatment process and then sent out for wastewater, for normal wastewater. Since the process began in 2009, by being able to treat the D002 waste, the institution has saved over $50,000 in acid disposal costs. Nikki, you want to take it away for case study 2?
Yeah, thanks, Mel. So in case study number 2, we were working with a smaller school that had been using a lot of ether in many of their classroom and research experiments. These classrooms generated a bunch of expired chemicals. So one bottle was placed into the main accumulation area by a waste technician, and a couple days later, when they opened up the main accumulation area, to quote the person who found this bottle, the bottle of ether was jumping around like a Mexican jumping bean, violently, reacting within itself. That school was forced to call a high hazard team to come out and deal with their expired ether. Final costs from just that one bottle were over $10,000. At this point, Triumvirate began working with that school to instate a program to monitor and control the number of time-saving chemicals that were on campus and the length of time that they'd been there. We had also suggested that they begin using alternate solvents that were not peroxide formers when you're doing simple chemistry experiments, which made the campus a safer environment for both the students and the faculty and the neighborhood that the research institute was in. The school now spends less than $500 a year to dispose of time-sensitive chemicals and is a much safer place. In our final case study, we were working with a large public institution that was shipping waste quarterly. They would call a crew out to do a lab pack, and the crew was on site with 2 environmental specialists for 2 days, packing chemicals. They were charged over $25,000 a year per shipment. Triumvirate began working with the institution, and the institution decided to put one of Triumvirate's environmental specialists on site to assist with their waste consolidation and inspections. The school actually decided to start shipping waste more frequently, taking advantage of storage regulations. By doing this, they were only shipping full containers and containers that were at their 90-day limit. But by doing this, the school actually reduced its waste budget by over 60%. And they found that they were able to take some of the non-expired chemicals that came in as waste and redistribute them to many different departments on campus. So before we get to the question and answer portion of our presentation today, we want to make sure that we got our key messages across. We hope you have learned how to use the regulations and waste minimization options to improve your waste management process and to achieve your organizational goals. And in doing this, we hope that you understand how your waste is generated at the point of generation. And given the regulations, we hope you understand what opportunities exist for waste minimization and cost reduction. And finally, we hope you see that maintaining accurate records help to ensure proper storage and disposal. I want to thank everybody for taking time to attend, and I'm going to turn it over to James now.
Thank you, Nikki, and thank you, Mel. I hope everybody got some ideas here, some new ideas for saving time and money in managing hazardous waste at your own institution. And I encourage you to stick around. We're going to do some questions and answers right now. and just before that, talk a bit about our follow-up. One of the most popular questions we get is, will we receive a copy of the recording and the presentation? And the answer is yes. Tomorrow you'll receive an email with a link to the recording as well as the slide deck. We'll also include a link to a survey. So we'd really appreciate your feedback, any ideas you have for new topics that we could cover, areas for improvement, let us know. We're always listening. And in addition to that, I also mentioned early on that we'd be making a special offer at the end of the webinar. Nikki and Mel spent a lot of time talking about disposal strategies and waste minimization options earlier, and we'd love to offer you a waste management review, a free assessment. So what I'm sending across in the chat box is a link to that offer, and if you get a chance, take a look at that while we're going through our questions today, and feel free to submit that very brief form, which will allow us to reach out and discuss your specific waste needs. So this assessment specifically, what it includes, is a facility walkthrough, a gap analysis, and recommendations for improvement based on your company goals. So we'd love to work with you to find some opportunities for saving. And in addition to hazardous waste management, our experts provide consulting services, emergency response, lab moves, among other EHS services. So feel free to reach out. I've got Melanie's email address there as well as Nikki's for those who are in Florida and the Southeast region, and the general phone number for Triumvirate. And without further ado, let's get to those questions, and we'll start with the few that have come in early, and we'll take those that come in live as well. And we've got about 15 minutes, so get those questions in, and we'll do as many as we can. To start, and this one's open to both of you, Nikki and Mel, what does a high-haz team consist of, and when is it necessary to call one?
I can start.
Sure.
That's a really good question. In typical, a high-haz team would be needed if for reasons that the DOT would not allow you to ship such a chemical. There is a forbidden list by the Department of Transportation. So if you cannot get it on a truck to a disposal facility, that typically requires a treatment. If there is not a disposal facility that will accept the chemical in the state in which it is in, that would be another reason to call a high-haz team. And when a high-haz team is called, typically that is an early morning, a permit-driven event. The local fire departments are involved. There's a notification in the paper to allow everyone that the school is having such an event take place. It's not typically liked by a lot of schools. You want your name in the paper for good things, not having hazardous energetic materials on site. Nikki, do you have anything to add to that?
In addition, you absolutely want to avoid having high hazard teams come out because they are costly. In addition, you probably will end up having to come to work much earlier in the morning or much later in the evening, as these events cannot occur during normal business hours. Evacuation routes have to be set up, and they are extremely dangerous situations.
All right, thank you both. And if there are any follow-up questions, feel free to send those. We're just kind of going to go through the list here as they come in, so thanks, guys. Our next question, we'll start with Nikki, if you want to take a stab at this one. Do you have any tips for speaking with researchers to ensure that they comply?
Well, I know that can be a problem for many of the EH&S professionals. Sometimes it's having to change their way of thinking. As long as the researchers are not necessarily paying for disposal on their materials, you can start to discuss with them the hazards and the fact that they have no financial responsibilities for their materials being shipped off. So it is in their best interest to follow the guidelines. In cases where the researchers are paying for their disposal, you can actually assist them with adding in disposal costs to their grants, which will be awarded, allowing the researcher to use more of the funding for research and not for their disposal costs. In addition, just general education of what is hazardous in their laboratories may be necessary. Sometimes they're having researchers in biology work with highly carcinogenic materials, yet they don't understand the fact that they are working with carcinogens. They think they're just working with simple cell cultures or stains. Melanie, you have anything to add to that one?
You pretty much summed it up, Nikki, and I think educate is definitely the #1 way to persuade, if you will, researchers to get on board with how to manage their hazardous waste. I know I've seen a couple schools put, I'd say, a slideshow or a presentation together that was a snapshot of the waste from the point of generation onto the lab cart, down the hallway, into an elevator, down to the main, into a drum, to really make sure that the researcher understood what happens to the waste when it leaves and why it's so important for them to put accurate information on the waste tags and to put correct chemicals together inside a waste bottle. So I really think education is the #1 way to go.
Great point, Mel. And we talked a lot about main accumulation areas earlier, and this question gets to the satellite areas. What are the time limits for storage in satellite accumulation areas? Nikki, do you want to start with that? I know this probably differs by region, so maybe we can give some examples.
This is a kind of complex situation. The regional environmental agencies regulate this differently. In general, in the state of Florida, a satellite accumulation area can have one bottle not exceeding 55 gallons of each type of waste in a satellite accumulation area. They can hold that waste until it is full, and they have 3 days once the bottle is full to move it to the main accumulation area. At no time can 2 of the same bottle or same types of waste exist in the satellite accumulation area. Melanie, I'll let you take it from there.
We're fairly similar up here in Massachusetts. Almost all of those are exactly the same. The difference that we have up here is that 55-gallon maximum across all waste streams are allowed to accumulate in a satellite accumulation area. So that's the top of the list. Once you go over 55 gallons, you must start purging your satellite down to the main accumulation area and getting rid of some of the waste. Other than that, you can store waste in a satellite until it's full and or until you've deemed you no longer need the waste. At that point, you put the date on the bottle and then you have 3 days to move it down to the main accumulation area.
Great, thanks for those examples. And if anybody has any questions about areas in between, I know we're covering the north in New England and Florida in the south. We do have representative and experts in the Mid-Atlantic and North Carolina and other regions. So any state-specific questions, let us know and we'll get you in touch with the right person. Let's take a question here from Hillary. What are the most cost-effective ways to reduce disposal costs when shipping out wastes as lab packs? Melanie, do you want to start with that one?
That's a really good question. So much so much can vary to ship it out. You certainly want to look at where your lab packs are going and if there's any specific guidelines for the disposal facilities that may consider one such chemical more expensive than another. When shipping out lab packs, obviously you want to maximize the volume within the inner containers, so making sure you're using full 4 liters or 100 milliliters, And then when you put those into the outer drum, the one that's going on the truck, make sure you maximize the volume in there and that you are choosing it for the most cost-effective treatment technology based on the chemicals that are inside that drum. Nikki, anything to add?
The only thing I would add to that is that to pay attention to how many non-regulated materials are actually being shipped out with your hazardous materials in live packs. A lot of times solids in specific are pretty specifically solids will be packaged together for hazardous waste disposal as maybe a toxic item, and you have a lot of non-regulated salts in them. You take your non-regulated salts out, you can actually reduce the amount of toxic materials leaving the facility which are going for incineration, and you can send those non-regulated materials elsewhere for other disposal options.
Great, thanks, Nikki. Good points. And the theme of this presentation that Mel started with was managing waste upstream or chemicals upstream, which will help you save downstream. So just keeping that whole cradle to grave process in mind will help you as far as that goes. And let's do our last call for questions. I've got 2 more in the queue, so I'll give everyone a chance to sneak one more in there with the time that we have left. Let's do a question here. What is the proper way to dispose of animal carcasses post-experiment?
All good questions. So animal carcasses, the disposal is kind of state to state, so I do recommend looking at your local state for regulations. In general, if the carcasses don't have any free liquid and or they're not preserved in any chemicals, you can place them in a red bag, a bio bag, and send them out as pathological waste. If it does contain liquids and or has a preservative, then you should probably consult your hazardous waste vendor. And again, please look at your local state agencies for any stringent rules that they may have placed on animal carcasses.
Anything to add, Nikki, or are we covered there?
It's very similar here in Florida, so I would say we are covered for Florida as well with that response. Thanks, Mel.
Excellent. Noel wants to know if there are any databases to know what waste chemicals can be stored with other waste. Wants to.
James, can you repeat
Yep.
the question, actually?
Are there any databases to know what waste chemicals can be stored with other waste? Any databases to know? So any systems maybe? I know we had some questions earlier about other software.
There are software programs that can alert you. You can put in kind of what hazards don't go together and alert you to it as you do a chemical inventory. Lots of times I kind of just see more or less cheat sheets around, if you will. It says, not to put your organic acids with your inorganic acids, and obviously your water reactives with water, and halogenated and non-halogenated. But it's a really good question about software programs. In my experience, I've probably seen only a few just maybe trigger as you're doing it. It might trigger, hey, this has this hazard. But I can't remember the name. Let me do some research, and I'll definitely get an answer back out.
Sure, we can follow up with Noel. All right, good. So we've got one more here, and let's just take this question, which gets to online trainings that Triumvirate offers. Here we go. This is from Alex. Does Triumvirate offer training online for people who are managing chemical waste for a school? And I know we have, you guys might be able to speak to this further, but we do have training courses available. Most of those are centered around DOT training and various hazmat trainings in person. and we have online trainings as well. So we could follow up with specific courses to see if we fit what you're looking for, Alex. And I don't know, Nikki or Mel, if you want to talk more about training and what Triumvirate offers.
Yeah, on our website, the open enrollment trainings are IATA for shipping on air, your DOT, Department of Transportation Regulations, to help you sign hazardous waste manifest, your RCRA training as a generator of hazardous waste, some RCRA training, and then different levels of HAZWOPER training for emergency response. And those are on the website, and we also offer one-on-one client-specific trainings, whether that is for faculty, staff, third shift. It varies. Everybody, kind of needs help figuring out what trainings do they need, and part of this assessment can certainly help figure out where some gaps might be and where people just don't know what they don't know, and that's not their problem. That's not their fault, and we can help get through that.
Sure, and I just sent through a link actually to our training page. So that's in the chat box. Feel free to give that a look and you can see what we have available as far as in-person hotel trainings and online trainings.
Thanks, James.
Sure, and I believe that covers it. I think one might have snuck through here at the end. No, we're all good. Okay, so we got to all of the questions. I'm sure there might be some follow-ups as you review the material more closely. And you can respond or reach out to Melanie or Nikki, or you can also respond to my email when I send that out tomorrow. I think we can start to wrap up now. We have just a couple of minutes left. Any final thoughts, Melanie and Nikki?
Just thank you all for attending, and hopefully you had at least one strong takeaway that you can bring back and explain to others, and hopefully it helps improve your hazardous waste program.
Thank you from me as well, and please feel free to contact me if you have any further questions, and I'm always there to help. And to those of you attending the Hazardous Waste Conference next week, I would love to meet you. I will be there. Please stop by.
Great, and that's down in steamy Miami, so have fun with that, Nikki. Thank you both. I want to thank you for your time and for sharing with us today some strategies that maybe we haven't thought about before. Take care, everyone. Have a good one, and we'll see you soon. Bye-bye.